Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leave Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. 2012 question: a certain basketball player scores 60% of the free throw shots she attempts. During a particular game, she gets 6 free throws. What assumption or assumptions must be made in order to regard this as a sequence of Bernoulli trials? Okay, so from theory, there's 4 conditions that needs to be met for it to be called a Bernoulli trial. The first one are the probability of success is the same each time. And that's true in this case because she scores 60% of the free throw shots. The trials must be independent of each other. So that means whether she scores or not scores a particular basket, that has no bearing on whether she scores or not scores the next one. Okay, so because she scores 60% of them all the time, you assume the trials are independent. Okay, we do assume that there are only 2 outcomes. Well, actually, it's given, it's basketball. She either scores or she doesn't score. Okay, and there has to be a finite number of throws. They're the other 2. And there is, in this case, there's 6 free throws. So they gave us 2 of them, the finite number, so that was 6, they gave us only 2 outcomes. It's basketball, she scores, she doesn't score. So the assumptions we're making are the probability of success is the same each time, and the trials are independent of each other. So that's part A. Part B then, based on such assumptions, so in other words, we're presuming it's a Bernoulli trial, find, correct to 3 decimal places, the probability that 1, she scores on exactly 4 of the 6 shots. Okay, so she scores 4. Okay, so in maths language, that is the probability that she scores 4. Okay, so Bernoulli trial. Okay, so out of the 6 shots, we want her to score 4 of them. Okay, we're calling a success a score, and our failure is our not score. Okay, so we always have our success here. So if she scores exactly 4, I'm saying out of the 6 shots, I want you to score 4 of them. Okay, the probability of scoring is 0.6. Okay, it has to be a decimal. So that's the 60% converted to a decimal, and I want to score 4 of them. So the probability, so this is 60%, which is 0.6. The failure then is 40% because obviously it has to add to 100, or 0.4. So if I'm going to score 4 of them, I'm then going to miss the other 2. Okay, so there's my 6 shots accounted for, my 4 scores and my 2 not scores, so they should add up to this 6. And then you just put that into a calculator. Okay, so 6, choose 4, so that's that NCR button that hides behind the divide by sign. So 6, choose 2, multiply by 0.6 to the power of 4, multiply by 0.4 to the power of 2. And I am getting 972 over 3125, or 0.31104. Yeah, so it didn't say to a certain number, to 3 decimal places, so 0.311. So a 31.1% chance that she would score 4 shots out of the 6. Okay, the second one then, she scores for the second time on the 5th shot. She scores for the second time on the 5th shot. Okay, so she takes 5 shots, 1, 2, 3, 4, 5. So on the 5th shot, she scored for the second time. Okay, so therefore, out of these first 4 shots, she must be scoring once and missing 3 times. Okay, because an event has to happen in all of them. Okay, so if she's scoring for the second time out here on the 5th shot, then out of the first 4 shots, she must be scoring the first time, and then she must be missing 3 times. Okay, so let's work that out. Okay, so out of these 4 that's here, and then this one. Okay, and of course it's the AND law of probability, so we're going to multiply them all. In other words, she's going to score and miss and miss and miss here, and she's going to score here. So all of these probabilities are going to be multiplied by each other. So the probability of her scoring is 0.6. Okay, so that's what's going to happen on the 5th shot. Then out of the first 4, so again, I'm going to use the same success and failure that I used up here. Okay, so out of those 4 shots, I want her to score once. The probability of her scoring is 0.6, and therefore she must be missing 3. So that's the first 4 shots by the 5th shot, and it's not telling us anything about the 6th. Okay, so put that into the calculator. So 4, choose 1, multiply by 0.6, multiply by 0.4 to the power of 3. And I'm getting, multiply by, I forgot my 0.6 at the end. So I'm getting 288 over 3125, or as a decimal, 0.09216. So round that to 3 decimal places, 0.092. Okay, so a 9% chance. Okay, and it's quite low because she scores 60% of the time. So chances of her missing 3 and only scoring 1 there is a bit slim. Okay, or the chance of her only scoring 2 out of 5 is a bit slim. Okay, so 9%, 0.092. So an important question to be able to work with Bernoulli trials and to do the calculations, but also to know the 4 conditions that makes a trial a Bernoulli trial. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.